Amazon just asked this question 17 times over the past 6 months. We are given the array and each value indicates the maximum jumps you can make at this point. For example, if we are on the first element, you can jump 1 step or 2. The maximum is 2. And we need to return true if we can start from the first element to jump to the last element. In this case, if we made 1 jump from the first and then 3 jumps, we can finally reach to the destination. Another example will be from the previous steps. All the elements we can jump, the maximum we can reach is on the 4th element, and on the 4th element we cannot make any jump. So there's no way we can jump to the last element, therefore return false. I'm going to quickly talk about the subsequence approach. Let's define index I and j, and the index j means the subsequence starting from I plus 1 to the maximum step on the nums. So for example, if I is on the first element, then j is it can go up to the 3rd element, and we can repeat the step until we see if we can reach to the last element. However, in the worst case scenario, I can take on time and then j can take on time as well. So the total time complexity is on squared, which is not what we want. I'm going to talk about a better approach called Leftmost Jump backtracking. So suppose we have this leftmost variable on here. That means starting from 0 to I, this subsequence, you can make the jump to this node. And this is called backtracking because let's say initially, we already know that we can reach to the last element. So every time we need to backtrack to see if we can go back to the original point. If the leftmost, the variable can update to the first element, that means we can jump from the first to the last. So we have the following relation that if current I index plus the step, the maximum steps we can take, that is greater or equal to the leftmost variable. That means the leftmost variable must exist on the left side of the I. And that means the current leftmost variable is not actually the leftmost. So we need to update to I. So from right to left, if we can continuously update the leftmost variable from the last element to the first element, that means we can actually jump to the whole thing. Another example, if you look at this array, we know that the jump will be stuck on this element, the 0. So if we declare the leftmost variable on the last element, there's no way that if even we are looping through from the right to left, there's no way we can jump to this spot. So the whole result will be false. And luckily, this Python approach beats 97% of the user. If you like this channel, please click like and subscribe. Thank you.